What we're going to be doing today and probably part of tomorrow. This has got a little bit more algebra in it than what we've been doing lately. We're going to be able to show that two lines in a coordinate plane are parallel by comparing their slopes and solve problems with that. And then we're going to show two lines in a coordinate plane are perpendicular by comparing their slopes and use that information to solve problems. So just a quick review, what does it mean if lines are parallel?
If they're parallel,
Yes.
that they don't intersect.
They do not intersect. So parallel lines look something like this.
Just think of a way an equal sign.
Like an equal sign or like railroad tracks or... Now,
The things that's holding up our trophy.
think back to algebra and when we talked about slopes of lines. What would you say about the slopes of those two lines?
They're the same slope.
They're the same, yes. So that's what we're going to be talking about. Parallel lines have the same slope. And then we're going to also be talking about perpendicular lines. So what are perpendicular lines?
Aren't those they cross, right?
They do intersect. They do cross. Not equal. There's a special way that they intersect. When perpendicular lines intersect,
90-degree angle.
correct, they form 90-degree angles at their intersection. So you may or may not have learned about their slopes, but we will talk about what slopes of perpendicular lines look like as well. It says here, a hill and a gondola line 20 feet above the ground goes up a hill, and they both have a slope of 1/2. What is the geometric relationship between the hill and the gondola line? Okay, so you can imagine like right here is your ground. Let's make it green.
Ain't a gondola one of those like cool elevators you sit in but in the sky?
Not an elevator.
They're like the box things.
Yes, it's a box in the sky, kind of like a sky lift. If you've ever been to like Ober-Gatlinburg or they've got gondolas at Disney World now
I
too.
haven't been to Disney World, no one's been to Gatlinburg since my uncle got shot there.
So here's the ground, and here's the gondola line. It's 20 feet in the air, right? So now it says that there's a hill that starts that has a slope of 1/2. Okay, so this is the part we're going to focus in on. We're going to focus in on the hill that has a slope of 1/2. So let me get my graph out here. So remember, slope being 1/2 means I'm just going to pick a random point to start. So I'm going to start right here. Now if I go up 1 and right 2, up 1 and right 2, up 1, right 2, up 1, right 2, then that's the slope of my hill. Right? We're going up 1, right 2, all the way through here. There's my line. Now the gondola is 30 feet above it. So let's say that right here represents 30 feet. All right, what's going to be the slope of the gondola?
1/2.
It's going to also be 1/2. Up 1, right 2, up 1, right 2, up 1. Because it has to maintain that 20-foot distance between them. So it says, what is the geometric relationship between the hill and the gondola line? So how could we describe these two? We could say that they are parallel. They have the same slope and they are parallel. I'm going to show you their drawing because obviously they can do a little bit more. Theirs. You see here they drew the ground, which went through the origin, and then they made the y-intercept be 20, and they drew their gondola line. And you see how those two are parallel, and they have the same slope. Are lines K and N parallel?
Yes.
Okay. Well, it kind of appears that they are, right? But in order to be able to say with certainty, I need to find the slope of both of those lines.
They're. Oh no, actually.
So to find the slope of K, I've got to pick 2 points on line K. So what 2 points am I going to choose? I'm going to choose points that are on crosshairs. So that this point is exactly on a crosshair. That makes it a good point to choose.
2, -3.
2, -3 is also a good point to choose.
2, 1.
Okay, 2, 1 would be here.
They don't cross on
It's
one.
not exactly on a crosshair.
1, 2 does.
Okay,
Yeah, that's what
let's just do K first. So I've got K. Now let's find the slope of K. So how can we find the slope?
Rise over run.
Yes. So you've got 2 options. I'm going to show you both of them. You can choose either one you want to on this problem, but you're going to need to know both depending on the problem. The fancier way to do it, the more math way to do it, is to use what's called the slope formula. M equals y2 minus y1 over x2 minus x1. If they give you 2 points and you don't have a graph, this is probably the best way to do it, because you just plug the points in. Okay, and I'll work that way out in just a second. But if I were given this problem where it's already graphed and I want to find the slope, I'm just going to find the rise over run on the graph. So I'm here. How much do I have to rise to get to this point?
5.
I'm going to go down 1, 2, 3, 4, 5. Now I'm on the same level. So I went down 5. So that means my rise is -5. Over, how much is my run? Well, I went right. 1, 2, 3, 4. So I would get the slope here to be -5 over 4. Just by looking at it. Alright, now if I had to plug those in, this is what we would have to do. My ordered pairs are -2, 2, and 3, 2, -3. So if I plug those in, I'm going to make this x1, y1, x2, y2. I would go y2, which is -3, minus y1, which is 2, over x2, which is 2, minus x1. So that would be minus -2. Well, minus -2 is the same thing as plus 2. So that leaves me with -5 over 4. Right? Either way, you can choose either way you want to do it on this problem. But you should find the slope of K is -5 over 4. Now you guys try to find the slope of N. Hello? Hey. No, it's 4th period. Yes. At 44. Yeah. Hmm? Okay, did we find the slope
I did.
of n? Okay, so I'm going to look for two nice points. So I would pick this point
Before -2.
and this point. Alright, those are definitely the two best points to pick. Now if I figure out how much did I rise, I went down 1, 2, 3, 4. And I went right 1, 2, 3. So I could say the slope of n is -4/3. Was that the same as -5/4?
No.
No. So are they parallel?
No.
No, they are not. And I know that they are not parallel because they do not have the same slope. Did they look parallel when we first looked up there?
Yes.
Yeah, so you can't judge it just by looking. Okay, you have to find the slope. Can I erase this?
Yes.
Okay, we got another one for you guys to try. I bet you can guess what it is.
Another one.
What's it going to look like?
Probably M and Q.
Yeah. Is M and Q parallel? So, if you're having trouble seeing it up here, you can look in your book. It's on 93. It may be a little bit easier to pinpoint our points from there. Next thing we're going to do is talk about perpendicular lines. So the book says two non-vertical lines are perpendicular if and only if their product of their slopes is -1. So what does product mean? What's the product? Answer to a multiplication problem. So this is saying if we multiply their slopes, we should get -1. Okay? Another way that we sometimes say it is we can say that their slopes must be opposite reciprocals. So here's what that means. If the slope of my first line is 3/4, then the opposite reciprocal
4/3.
would be negative, that's opposite, reciprocal, 4/3. These two slopes would give a perpendicular line. If my original slope was -1/2, then the opposite reciprocal would be positive 2/1, which is just 2. Right? Opposite reciprocal slopes. That's the way you'll probably hear me say it. The book will say their product is -1. I say their slopes must be opposite reciprocals. And you can see here, I have my perpendicular lines. Now, if I have one line that is vertical and one line that is horizontal, then those also give perpendicular lines. But we can't use this same logic because the slope of a vertical line is undefined. So they can't treat it the exact same way. Now we want to know, are J and K perpendicular?
Which one's J? Is that one in the right? No, right there.
Okay, so right here it tells me J is here. So this is line J. So if I'm looking for two good points for J, I like this point.
And 2 and 1, 2. 1, 2. Yeah, 1, 2.
1, 2. Okay, I like that one. So how much did I go up? I went up 1, 2, 3. Left 2, so it's -2. So the slope of J is -3/2. So if they are going to be perpendicular, what does K's slope have to be?
Positive.
Positive 2/3. Right? Opposite, reciprocal. So if K is 2/3, then they are perpendicular. Let's go to K.
0, 4.
K is here. So I've got, I like this point,
And there's a point at 0, 4.
and 0, 4. Okay, I like that point. Let's see what my slope is. I rose 2. I went right 1, 2, 3. So the slope of K is 2/3. So are those perpendicular?
Yes.
Yes, they are, because they have opposite, reciprocal slopes. Any questions? Okay, I want you to try these. Okay, so it tells me to write an equation of a line that goes through the point P. I need to go through this point, but it must be parallel to line L. So what does it mean if they are parallel? They must have the same slope. What is the slope of this line?
Oh, y equals 1/2 is this slope.
It's 1/2. Remember, if this is in y equals mx plus b form, then that means my m is the slope. So that means 1/2 is the slope. So again, we can double check it, right? If this is the point, I go up 1, right 2. Yeah, I'm doing good. So I need my line to have the same slope. Okay? So I know a point on my line. It needs to go through the point for 1, and I know the slope of my line. The slope is 1/2. Right? Because I need it to be parallel. So I know the slope needs to match. What I'm going to use is called point slope form. Y minus y1 equals m times x minus x1. Have you guys seen that formula before?
For I think
Point slope form.
for last year.
Okay. So when we do, we're going to plug in for y1, m, and x1. You're going to plug in for all of those. This y and this x are going to stay y and x. They don't change. So this is my point, 4, 1. So that means this is my x1, y1. Because that's my first order pair. And then again, my slope has to be 1/2. So that is my m. So I have y minus y1, which is 1, equals m times x minus x1.
You get negative 4m, right? No, never mind, I put it wrong. I didn't figure out about the half.
Everybody with me? Now we have to distribute here. So 1/2 times x is 1/2 x. 1/2 times negative 4 is negative 2. So I have y minus 1 equals 1/2 x minus 2. And then we have to add 1. So it tells me y equals 1/2 x minus 1. So this is my equation of a line parallel to this line going through this point. Any questions there? The next part of the question is, what if I want it to be perpendicular to this line? Okay, so it's the exact same setup, but instead of finding a parallel line, I want to find a perpendicular line. One that's going to intersect it and form a 90-degree angle.
You can go down from P, you can go down one, like right to
Okay, so what do we know about perpendicular slopes?
cross.
No. Perpendicular slopes.
Have it perpendicular. They have the same slope, but reversed.
Opposite reciprocal slopes. So I know the slope of the red line is 1/2. So what's going to be the slope of my line?
-2.
-2 over 1. Because I changed the sign, opposite, reciprocal. So I know the slope is -2 over 1, which we can write as -2. And again, I know a point on my line. The point is 4, 1. And it's the exact same process. The only difference is I have a new slope. Right? So I'm going to plug in y minus y1 equals m times x minus x1. That's going to give y minus 1 equals m times x minus x1. And now I'm going to distribute. This is going to say y minus 1 equals -2x plus 8. Add 1. Y equals -2x plus 9. So that's the equation of a line perpendicular to the given line through that point. Okay, so this one, I'm going to look at A part. I'm going to work the first part of A for us. It says we want the equation of a line parallel and perpendicular to the given line K passing through the point T. So I'm going to so every A part's going to have 2 answers and B part's going to have 2 answers. I'm going to start with parallel. So parallel are the lines that never touch, never cross, like railroad tracks. So I need to write an equation of a line that is parallel to this line, but it has to go through this point. So what did we learn yesterday? We learned parallel lines have the same slope. They have to have the exact same slope. So when I look at this equation, it is in slope-intercept form. Y equals mx plus b. So that means whatever number is in front of my x, that is the slope of that line. So the slope of the line is -3. And if I want my line to be parallel to that, then I know the slope of my line must also be -3. So I know the slope of my line, and I know a point on my line. When I know a point and the slope, I'm going to use point-slope form. So point-slope form looks like y minus y1 equals m times x minus x1. So when I'm plugging in, -3 is going to be my m. 3 here is going to be my x1, and 1 is my y1, because they're the x and y of the ordered pair. So when I plug in, I'm going to go y minus y1, which was 1, equals m, which is -3, times x minus x1, which is 3. Everybody see where I got those numbers from? I tried to color coordinate it for you. You kind of see where I'm plugging in and what's going on. Now, once you've done that, you've done all of the work that you have to think about. Everything else is just simplifying. So from here, you have to distribute. So that's going to be negative 3x and a positive 9 equals y minus 1. And then we need to add 1 to both sides. That tells me y equals negative 3x plus 10. So this is the equation of my line that is parallel to this line, but goes through this point. Okay, that's how we do that. So that's the first part of A. So I'm going to let you guys try the second part of A. Second part of A is now write an equation of a line that is perpendicular to this line. So what did we learn yesterday about perpendicular lines?
They're the opposite reciprocal.
They have opposite reciprocal slopes. So that means the slope of my line needs to be what? So the slope of their line is what?
Positive.
No.
Negative.
The slope of their line is negative 3. So the slope of my line needs to be positive reciprocal. What's the reciprocal of 3?
1/3.
Yes. So the slope of my line needs to be 1/3. So this is the slope. This is still a point. And so you're going to use point slope form to do that. Okay? So I've got you all the way to here now. So if you want to plug in using this new slope, see if you can figure it out. And I'm going to let you try B on your own.